Today, we're cutting through the noise to look at a really specific moment in history, the original AI wars. When you think AI today, you probably think processing power, maybe deep learning, Google, Facebook, that kind of thing. But we're rewinding. Back to the late 50s, the fight wasn't about data centers then. It was pure philosophy.
Yeah, it was about whether building a machine that could think like a human was even possible, like in principle. So our mission today is to unpack those really sophisticated philosophical arguments against AI. Why did that early dream of, general AI kind of fizzle out? And what does that tell us about the AI we use every single day?
It's a really interesting path back, actually, because the first major philosophical attack landed surprisingly early, around 1959. That's when J.R. Lucas, a British philosopher, presented his paper, Minds, Machines, and Gödel. Suddenly, pure math logic was right in the thick of it.
Okay, so this is the famous Gödel objection, the idea that AI is just logically impossible. That was the core claim, yeah. Lucas took Kurt Gödel's incompleteness theorems, which are pretty complex, but the gist is, Gödel showed that for any consistent formal system, basically, rules strong enough for arithmetic, there will always be true statements within that system that the system itself cannot prove. Let's call one of these G.
Right, so the computer, stuck inside its own rules, just can't prove G is true, even if it is.
Exactly. But Lucas argued humans can see that G is true. We can kind of step outside the system, look at it, and prove it. So his conclusion was, since a computer is its formal system, and the human mind can go beyond that system, well, the mind must be superior, non-mechanical. You can't build it out of code alone.
Wow. Okay, that sounds pretty definitive. That holds up. The whole project of building a computational mind just stops dead, right?
It felt like that to some people.
But I know the source material mentions a counter-argument. How did philosophy respond to something that sounds as solid as Gödel's logic?
Yeah, the rebuttal is key, and maybe less well known. It all hangs on this idea of meta-language. Think about it like this. There's a difference between talking about dogs. Dogs have 4 legs. That's an arithmetical statement, sort of. And then talking about that sentence, like, dogs have 4 legs, has 5 words. That second one is a meta statement. It's about the language itself.
Okay, so one level is the object language, the other is the meta language.
Right, and Lucas's argument kind of implied the computer had to stay stuck in its object language, unable to step up to that meta level to analyze itself and prove G.
But wait, when a human steps up to that meta level,
Yeah.
aren't they just following different rules, higher level rules? Couldn't a machine just be programmed with those rules?
Precisely. That was the defense. A computer can be programmed to shift from its internal language to a higher level meta language to verify G. It's just another layer of programming. Each time you climb a level, you're essentially in a new, more complex formal system. But the machine is still a machine, just following rules. It doesn't suddenly become non-computational.
Okay, so Gödel showed systems have limits, but not that you couldn't just build a more complex system or layer systems to get around those limits. The logical door wasn't slammed shut, just maybe complicated.
Pretty much. It dented the argument, but didn't destroy the possibility.
Okay, but then the battle shifted, right? Away from pure logic and towards meaning. This gets us to that core issue of intentionality or aboutness.
Yeah.
The argument here, as I understand it, is that even if computers follow rules perfectly, the process is meaningless to them. They're just unintelligent machines.
Exactly. This is where the focus shifts more towards psychology, you could say.
Yeah.
The core idea is straightforward. Computation is just a mechanical process. Think of a calculator. It spits out 2 + 3 = 5, but doesn't know anything about the number 2. Or addition. No. It's just circuits opening and closing based on inputs. The meaning, what the source calls derivative semantics, that only exists for us, the humans who build it and interpret the results.
Right, and this whole line of thinking really came to a head with John Searle and his Chinese room argument in 1980. That's a really famous thought experiment.
It is, and it does a great job highlighting this distinction between syntax manipulating symbols and semantics' actual meaning. So Searle asks you to imagine this. A person, let's say a native English speaker, locked in a room. They don't know a single word of Chinese, not a character. Inside the room, though, they have this enormous, incredibly detailed rule book, all written in English.
Okay.
And this rule book tells them exactly what to do with Chinese symbols that get passed in. If you see this squiggle followed by that squiggle, find rule 74b and output these other squiggles.
So they're just matching patterns and following instructions, purely procedural.
Exactly. Input comes in, they consult the book, follow the rules, output goes out. Now, outside the room, native Chinese speakers are passing messages in and getting responses back. And the responses are perfect. They're coherent, maybe even witty. The people outside think, wow, whoever or whatever's in that room understands Chinese fluently.
But the person inside, they haven't learned any Chinese at all. They're just shuffling symbols they don't understand.
That's the crux. The person is just manipulating symbols based on rules, that's syntax. But they have zero understanding of what those symbols mean. No semantics, no content.
And So's conclusion is devastating for AI then. A computer is just like that person in the room, or maybe the whole room system itself. It's just doing syntax.
Right. It's manipulating symbols, maybe very impressively. But if thinking requires actual understanding, genuine content semantics, then the computer isn't thinking. And maybe it never can, if it's just a syntax machine.
And you're saying this is basically why that initial push for like a truly human-like general AI sort of stalled out in the 80s.
That's a big part of it, yeah. It wasn't about computing power limitations back then. It was this deep conceptual problem. We're building amazing syntax engines, but it didn't seem like more syntax was ever going to magically turn into semantics. Understanding just wasn't emerging.
Which, okay, leads us kind of neatly to where we are now, because we obviously didn't stop building AI, we just changed the goalposts.
In a way, yes. We largely gave up for a time on strong AI, that dream of general human-level intelligence, and focused on what works. Mono-intelligence, sometimes called weak AI.
Right, AI that's incredibly good at one thing.
Exactly. And these mono-intelligence systems have exploded because they kind of sidestep the whole semantics problem. Deep learning models. You could argue they are the most sophisticated syntax machines ever created. They are phenomenal pattern matchers and processors for specific tasks, often far better than any human.
And we see that everywhere. AlphaZero destroying humans at chess and Go, DeepStack in poker, Watson on Jeopardy. These things are specialists.
Brilliant specialists. But they also show that brittleness, that lack of real understanding, which Searle pointed to. AlphaZero can be the best chess player on the planet, but it has literally zero concept of what a king is or a board, or even that it's playing a game. Its cognitive world is incredibly narrow compared to the humans it beats.
Okay, so this very limitation, the syntax without semantics thing, is now causing new problems, new ethical battles.
That's the critical connection, the philosophical problem. The failure to achieve genuine understanding, it translates directly into real-world ethical challenges when we deploy these systems.
How so?
Because these specialized, quote-unquote, unintelligent systems are being used for critical decisions. Think predictive policing, loan applications, even medical image analysis. And because they lack world understanding, they often just replicate and amplify biases hidden in the data they were trained on. They become, as the source material puts it, embarrassingly sexist, racist.
Wait, I remember reading about Joy Buolamwini's work, the AI researcher whose face wasn't detected by facial recognition systems.
A perfect example. The system is a fantastic pattern matcher. That's its syntax. But if its training data is mostly, say, white male faces, it fails miserably when it sees something different. And crucially, it doesn't know why it failed. It doesn't understand face or identity or bias. It just knows the pattern didn't match well enough according to its rules. No semantics.
Just pattern matching, no insight. And this lack of insight must get really dicey when these systems have to make split-second decisions with serious consequences.
Hugely dicey. Which brings us to things like autonomous vehicles, AVs, and lethal autonomous weapons systems, LAWs.
Yeah, the trolley problem, but automated.
Pretty much. These systems, by design, might be forced into situations where they have to make an optimization choice in an accident scenario. Swerve and hit pedestrian A, or stay course and hit pedestrian B, or risk the passenger.
And the philosophical worry there is what's called moral abdication.
Exactly. Our way as humans handing over fundamental moral decision-making to machines. If we program a car or a drone to make a choice that results in death, can that machine be held morally responsible? Of course not. It lacks consciousness, intent, the capacity for moral reasoning, an action that would be a war crime if done by a human soldier. Well, what is it when done by an algorithm? We risk letting ourselves off the moral hook.
So the obvious first thought is, okay, just program it with ethical rules, like feed it Kant's categorical imperative or some utilitarian calculus, maximize good, minimize harm, problem solved.
Well, most philosophers digging into this argue, no, that's probably not sufficient for genuine moral behavior. There's a strong argument from embodied cognition.
Embodied cognition, meaning our thinking is tied to our physical bodies.
Yes, and specifically, that our moral reasoning might be deeply connected to our physical experiences and, crucially, our emotions. There's fascinating neuroscience here. Studies on patients with damage to a specific part of the brain, the ventromedial prefrontal cortex, the VMPFC, which is linked to emotion.
Okay.
These patients often become terribly bad at making everyday decisions, even seemingly rational ones. They can logically list pros and cons, but they can't feel the weight or value of different outcomes because the emotional connection is severed.
Wait, so damage to the emotional part of the brain messes up rational decision-making. That seems counterintuitive.
It does, but it suggests that our ability to reason well, especially morally, isn't just pure logic. It requires emotional input, those gut feelings, the ability to empathize, to assign value. If genuine moral judgment, what Aristotle called phronesis or practical wisdom, needs this embodied emotional component, then a disembodied AI, just running code, might fundamentally lack the capacity for human-like ethical reasoning.
That's quite a thought. Our emotional bugs might actually be features necessary for morality, which circles back to trust, doesn't it? How can we ethically trust a system?
When we can't even know if it's conscious. Exactly. Consciousness is the ultimate subjective experience. There's something it's like to be you or me. But science can't objectively measure or verify that first-person experience in another being, let alone a machine. So whether a super complex AI is actually conscious or just an incredibly sophisticated simulation, it's potentially forever unprovable. And that bedrock uncertainty makes assigning true moral agency or trust incredibly difficult.
Okay, so the original AI wars, the philosophical ones, they didn't exactly end the AI project, but they definitely surfaced these deep, persistent problems, meaning morality, consciousness, things we're still grappling with today as AI becomes more powerful.
Absolutely. They remain highly relevant.
But if we put those aside for just a second, looking purely at the goal of general intelligence, what's the single biggest conceptual roadblock still standing? The thing preventing even our smartest specialized AIs from becoming truly adaptable and versatile like humans.
Well, arguably, we end up circling back towards logic, but in a different way. Not Gödel this time, but something called the frame problem.
The frame problem. Okay, what's that about?
It's fundamentally about relevance. How does an intelligent system efficiently figure out what information matters and what doesn't when something in the world changes?
Give me an example.
Okay, imagine you tell a sophisticated AI, I just poured a glass of water. What does it need to update in its knowledge base?
Well, the glass is now full, the water level in the pitcher went down.
Right. But crucially, what does it not need to recheck? Does it need to verify the color of the walls hasn't changed? Or that the law of gravity is still working? Or that Paris is still the capital of France?
No, of course not. That sounds absurd.
It sounds absurd to us because humans do this relevance filtering instantly, unconsciously. We just assume most things stay the same unless there's reason to think otherwise. But a purely logical AI, to be rigorously correct, it would have to check every single belief it holds about the world to see if it was affected by the water pouring event, which is computationally impossible. It would take forever.
So it's logically paralyzing. A system based on pure logic can't function in a dynamic world because it can't quickly sort relevant from irrelevant.
Exactly. Philosophers like Jerry Fodor argued solving the frame problem computationally would basically require having a complete scientific theory of everything. It's considered logically undecidable in its pure form. You can't guarantee a perfect, logically sound solution that's also efficient.
And humans do solve it, right? We function.
How?
If it's logically undecidable.
But we don't solve it perfectly or logically. We solve it heuristically. We make educated guesses. We rely on shortcuts, assumptions, rules of thumb. We guess and hope for the best, as the source puts it. Our intelligence isn't based on exhaustive logical proof for every action. It relies heavily on these fast, automatic, good enough processes.
So, like, when I lose my keys and waste time checking the same few spots, assuming they couldn't possibly be somewhere weird like the fridge, that's me failing at the frame problem.
That's you being a victim of your own heuristic assumptions. You implicitly decided the fridge's state was irrelevant to the key's location, and this time, you guessed wrong. That 1% failure rate is the price of 99% efficiency.
Okay, so if the key difference between our flexible general intelligence and the powerful but brittle intelligence of current AI is this ability to efficiently guess what's relevant,
Using these fast, sometimes flawed heuristic methods.
then it suggests something pretty radical about what intelligence actually is.
It really does. It suggests that maybe true adaptable intelligence isn't primarily about that slow, careful, logical deduction, what psychologists often call type 2 thinking. Maybe the foundation is actually type 1 thinking, those fast, automatic, intuitive, heuristic processes, the ones we've often tried to eliminate in AI development because they aren't perfectly rational or predictable.
So if the biggest hurdle is relevance filtering, and that requires non-logical heuristic guessing,
Then maybe the grand project of AI shouldn't be about building a perfect logician or a rule-following machine. Maybe the real challenge, the path to general intelligence, is building a really, really good guesser.
a system whose strength lies in its ability to make smart, efficient leaps of faith, not just follow logic perfectly. Something to think about next time your phone uncannily predicts your next word. Thanks for diving deep with us today.